In this video, we are going to be going over how do we react those alcohols that we learned how to synthesize in the previous video. So, understand that in the previous video, we learned how to make alcohols via reduction reactions. We learned that we could do this through hydrogenation conditions. We learned sodium borohydride, and we even learned lithium aluminum hydride as reagents. So understand that in order to learn how alcohols react, we can do the opposite. Instead of reducing to form the alcohols, we can take those alcohols and we can oxidize them and produce those carbonyl functionalities. Okay? Mainly, we are going to be focusing on the production of ketones, and aldehydes. So, when it comes to the oxidation of alcohols, remember that the alcohols that can undergo oxidation must have hydrogens at the carbon that is attached to the OH. That's why in oxidation conditions, primary alcohols, secondary alcohols can undergo oxidation. Specifically, as you can see, a primary alcohol will be oxidized to an aldehyde, or that aldehyde can be oxidized to a carboxylic acid. There's also ways in which we can go directly from primary alcohol to carboxylic acid. Secondary alcohols will always oxidize to a ketone. Ketones cannot be further oxidized. And as I explained before, tertiary alcohols, because they do not have, the bond to a hydrogen, as you can see here we have 3 R groups, they cannot undergo oxidation. So whenever you take a tertiary alcohol and you try to oxidize it, there is no reaction. Let's learn now the reagents for these oxidation processes. When it comes to oxidation of alcohols, understand that there's going to be 2 main reagents that you guys have to be familiar with. The first reagent is going to be chromic acid, H2CrO4. The other reagent is going to be PCC. As you can see, PCC stands for pyridinium chlorochromate. Okay. Now, when it comes to these oxidation reagents, understand that H2CrO4 is a strong oxidant, while PCC is what we call the mild oxidant. So let's observe what happens when chromic acid actually reacts with a particular alcohol. Let's say that, for example, we have a primary alcohol. If we reacted with H2CrO4, in other words, chromic acid, understand that at first that primary alcohol will form an aldehyde. But this aldehyde under those conditions will not stay. The final product of the reaction will be the formation of the carboxylic acid, because under strong oxidation conditions, the primary alcohol will turn all the way to the carboxylic acid. It will not live at the aldehyde. Now, I just mentioned that PCC is a mild oxidant. So what that means is that PCC can be used to stop at the level of the aldehyde. And that's what we observe. If a primary alcohol is reacted with PCC, and as you can see, CH2Cl2, that is just the solvent of the reaction. Just understand that you can include it, but you don't need to include it. That primary alcohol will form specifically the aldehyde. Now, understand that when it comes to this, it's very important to distinguish how strong my oxidant is going to give me the functional group that I need. Now, moving right along, if we have a secondary alcohol, it doesn't matter if I use chromic acid. And again, these reagents that you have here produce H2CrO4. So you can choose to write H2CrO4, or you could do all three reagents, which is how you synthesize. That is a sodium dichromate, sulfuric acid, and water is what produces H2CrO4. So you can choose any of the two sets of the reagents. Going back to the reaction, if we have a secondary alcohol, it doesn't matter if we use a strong oxidant or a mild oxidant. There's only one end product, and that's going to be the ketone, because the product of the oxidation of a secondary alcohol is always a ketone. And remember that ketones cannot be further oxidized. As I just mentioned a few moments ago, remember that tertiary alcohols will not react with any of these oxidants, so that's why there's not a slide about it. So overall, as you can see, this last slide shows you the majority of the reactions that you should have learned in first semester organic chemistry. My recommendation for you is review them. Understand the mechanisms for substitutions, eliminations, and Grignards. Make note cards in order to remember these reactions, because they're going to play important roles in second semester organic chemistry, because they give rise to many of the functional groups that we are going to be talking about this semester.